Hi, welcome to the stage, Ellen Bowen, the Senior Vice President and Global IoT Strategy and Operations at Keyfactor.
Thank you, Lucian. Hello, everybody. I'm excited to introduce the next topic for the day, and it is focused specifically around how we are thinking of securing industrial assets using certificates. And so we'll explain a little bit about what that means and why we think that this is a way that we can promote and establish more secure infrastructure, whether it's in our factories, whether it's in our environments. Lots of topics that we're going to jump into, but without further ado, I would like to introduce our key experts from my team as well. Joining us, we have Andreas Philipp, who is the Business Development Manager of IoT out of the EMEA region. So welcome, Andreas. Really excited to have a conversation with you today. And then Josh Carter, who is also Business Development Manager IoT out of the US, and a lot of background and great conversation that I'm sure he is going to add as well. So welcome, Josh.
Thank you. Glad to be here.
So the topics that we're going to cover today are PKI, which stands for Public Key Infrastructure in the smart factory. We're going to give you some best practices based on what we have actually been seeing, projects we've been doing with customers, and what we're seeing when it comes to guidelines and standards and eventually regulations. Part of it also will go into device identity. What does that really mean? How do you identify endpoints or pieces of equipment or stuff within the factory or within the environment that you want to securely connect to? How do you do that, and how do you leverage certificates to be able to do that? So really, we're seeing this space emerge and having many more conversations about this, especially in the past few years, because we are seeing this convergence of IT and OT. And I know we'll go into this a little bit with the speakers here, but no longer is we'll just air gap off this environment and we're secure, right? Because anybody knows that if someone can get into that facility, get into that factory, then anything is game in terms of hackers being able to get into our system. So how do we then have the right sort of infrastructure and security layer within that? So to kick us off here, I'm going to pass this over to Andreas can you define what is the smart factory? What are you seeing? And how can we start this conversation today?
Yeah, thank you. I think when we are talking about smart factories, especially here in Europe and also in the German machinery manufacturing side, so we are talking about Industry 4.0 concept, but in the end of the day, we are talking about the digitalization. So bringing the internet connectivity down to the shop floor and connected our machines into IP-based networks and collecting data and information out of this processes and these workflows and aggregate them into platforms and systems to derive benefits and derive KPIs and derive also remote control mechanisms. What we learned and when this digitalization and these concepts were introduced into the market years ago, it was absolutely clear that cybersecurity must be an essential part of this initiative and must be a mandatory point in the whole standard or in the whole concepts and standard that are developed around these. And so that happens. I think it was years ago, when all these concepts came up. And now over the last years, again, also standards and regulations are closing now the gap between the first starting point, the first concept, and the standards are coming in and bringing some lights into the concepts, how to implement this, how to adapt this functionality, and also what about the security and what about the security requirements now when it comes to this digitalization. And we will come later on and we show you a picture how we see this world of industrial cybersecurity market when it comes to regulations and standards. But to be honest, and then that must be absolutely clear also upfront, there is still room to improve. So we are on a very good step, on a very good way to. We are making very good steps in the right direction, but there are many question marks and open areas, wide open areas where we have to work on and where we have to fulfill it. And that is also what we later on address when we are diving a little bit deeper into the device identity concept itself. But let me close this slide here. And one learning and one point that we see is either we are talking about NIS2 directive here in Europe or the 62443 framework. PKI is one of the major building blocks for establishing trust and security in this environment. That means X.509 certificates issued by infrastructure is one building block that it is in the end of the day mandatory for this. So let's go to the next slide, and then we are talking a little bit about the change, of the whole philosophy. I'm talking about the digitalization, and let me click to the next slide, and maybe Josh, you can jump in, and talk a little bit about the change of the old model, how this market, how the industry is working, and what changed with the new Industry 4.0 and digitalization concept.
Yeah, sure. So I think the use of PKI and certificates in the IT world is well understood, and in the OT world, there's, like you said, there's a lot of questions. There's a lot of ways to improve. I think in the past, they thought the factory was the perimeter, air gap, security by obscurity. What was the way to go? These machines were designed to function, and they were supposed to function for a long time. And I think the operators and the people in the factories are more focused on safety. That's very important to them, and keeping things running. So they'll do whatever it takes to keep the machine running. If a safety mechanism isn't working, they'll bypass it. They're focused on that sort of thing, and security less. But now with IT and OT convergence, the attack surface is enlarged, not just for the plant, but also for the data center and all the connected devices and applications. So on the left here, you use the Industry 3.0, the Purdue model, and everything's kind of rolling up, kind of one way to visualize it. On the right, you see Industry 4.0, and you see everything's connected to one another. There's all this great, rich data on the machine, and you can take that data to the cloud and do predictive analytics, prescriptive analytics, apply machine learning, artificial intelligence, and these old technologies like air gap, and those things are kind of standing in the way of progress. So there's a lot of value that can be extracted from these machines, but air gap works until it doesn't. I've got steel-toe boots and a hard hat in my truck. I've done plant walkthroughs, and when you walk through a plant, you see some wild things. You'll see residential modems behind routers. You'll see edge devices and EWANs attached to machines that allow remote access from vendors. These things are aggregating data and pushing them out to the cloud to who knows who. You've got networks that were put together a decade ago by who knows who. So, I think that the people in the plant and the manufacturing facilities they have a lot to learn. And I love the fact that the standards are all coming in and kind of enforcing some of this policy, because like I said, this, the perimeter is no longer the building or the plant. It's now the device. It's the identity. And I think it's important, a building block, like you say, Andres.
Right.
Awesome. Well, thank you guys for those introductory thoughts. So, all right, I'm just going to remind everyone, if you have a question, put it in the Q&A. We will get into those either throughout the session or at the end. We want to have this interactive. And then also to maybe kick off some more audience participation, I'm going to start a poll. So let's see here if this works. Want to try to get some feeling for how familiar you are specifically, or your organization is, with certificates and keys that we've just basically introduced here. Are you using them to secure your assets? And if so, do you have an understanding of that, or really no visibility, no understanding? So we just want to get just a rough idea of where the audience stands in this so that we can, again, kind of tailor some of the conversation. So I want to give it just another 10 seconds. And viewing the results here. Okay, great. So guys, I'm just going to read them off. So Andreas and Josh, please maybe comment a little bit on this, but it feels like of the three choices, you're completely aware, you're somewhat aware, you have no visibility. I guess I'm encouraged to see that only 12% of people have no visibility and no understanding. So I think maybe if you can kind of comment on that, and 60% of people are somewhat aware. So I guess that's somewhat positive, but any comments on that? You know, if we're polling the audience here, did you expect that result where most people seem to be somewhat aware and very limited have no visibility? What are your thoughts on that?
No, I think, to be honest, I think that's for me. I don't have, I don't have expect this high rate of acknowledgement. Yeah. So when working here or giving also here in Germany lectures to the industrial automation industry and the machinery building industry, we have a complete other picture. Yeah, we have a complete other picture. So a lack of acknowledgement about security, secure implementation, missing experts in the market when it comes to employees. That's heavily. Siemens is putting out initiatives to avoid self-signing certificates. So they are rethinking about deleting all the chapters in the manuals for all the controllers where they are explaining how to generate self-signed certificates or unmanaged certificates, these ticking time bombs. So
Yeah.
it's I think on the other hand side, it's perfect for us. So we can start here and then talk a little bit deeper on some other time.
That's great. That is great. Okay, I'm going to do another one. So I want to understand from the audience who is responsible for this strategy. Okay, so again, whether it is it the IT organization that is driving this, or is it the OT, you know, in the factory, sort of moving over into this more IT space? Do you have a partner? Is it a third party managed service? So maybe give us some perspective from your side. If again, we have a decent number of people that are mildly familiar, who is driving this? So I'll give it about 10 more seconds. Okay, so again, of the choices here, the top one is with 41%, the IT organization. So 41% of people, IT organization is driving industrial cybersecurity strategy. Second is OT, the OT organization with 20%. So very interesting. I don't know, Josh, do you have maybe thoughts on that one? Like I would have maybe, you know, IT has, again, the expertise, but then OT knows the environment. So kind of what do you think about those results there?
I guess it just depends on the size of the organizations. You know, some places there's just not enough, you know, budget, or you know, the IT and OTs combined. And some organizations, as they get larger, they separate, and then they have a security team. So I think it varies a lot there. So based on the organization, I think another big driver for these type of technologies is standards like OPC-UA and MQTT that are starting to be more and more relevant and more accepted by the industry. Those things require 509 certificates for encryption and communication. So a lot of organizations, they grow through acquisitions. So maybe you're standardized on Allen Bradley, but then you acquire this facility that's using Siemens, this other one's using B&R, and next thing you know, you've got all these different languages and that they don't communicate to one another. And so OPC-UA is like the Star Trek universal communicator, and it kind of allows them all to speak machine to machine and machine to cloud. And that has to be secured. So I think not only the regulations, but the industry standards, I think those type of things are going to drive this. And I think that IT and OT need to start talking together more and communicating using a common language. I think that's going to be very important because they use different tools. They speak different languages. IT's worried about printers and, mouses and, servers and email, and the OT guys are looking at rewinders and sifters and conveyors and 6-axis robots, so that they deal with different things. IT's used to security. The OT guys are trying to keep things running, and they're worried about safety. So I think the IT and the OT organizations definitely have to come together. And I think
Got it.
Yeah.
Great insights. Okay, one last question. All right. So would love to understand, how much are your organizations adopting cloud? Okay, so Josh mentioned a little bit about cloud. Andreas also, but do you have high adoption? Are you all in? Are you about half and half, or is it low and slow to adopt? Would love to get an understanding here from the audience. So give it about 10 more seconds. Okay. Actually, somewhat even split, somewhat of an even split, but 40%. So the biggest number here, the majority say high adoption. Oh, no, high to medium. All right. So we got 40% for high adoption, 40% for medium, and then 20% low. So maybe Andreas, any thoughts on that? Like, I know you've been in the industry a long time. So what are your thoughts on cloud adoption, and does this surprise you?
Maybe, no, it doesn't. It doesn't surprise me. Maybe I skip to the next slide because we have prepared. We know the answer. And
all right.
no, I last week I was as a seminar here down in Austria, and we talked also about this topic, how the cloud adoption is now, or that we see that the industrial industry is also moving heavily into the cloud. Yeah, although we are here in Europe and everybody is a little bit not so trust. There's no trust, or the big trust in the cloud environment. But nevertheless, I think one reason is, and that is what we figured out, is that the manufacturing industry and the production industry has been on the top hit list for hackers in the last years, and they are facing ransomware attack all over the industry, and that costs huge amount of money to restructure the whole IT system and everything. One reason for that is that also the hackers, they know exactly these guys. They need they need more and more, and they're relying more and more on a function and reliable IT infrastructure, to keep their production processes up and running. And so hitting them and attacking them with ransomware, they know exactly they will pay. They will pay immediately because availability and connectivity is key for them. And that's one reason. And what we see, and what I learned is last week, is that after companies who were hit by ransomware and after the attack, the step moving into the cloud was absolutely clear. And was a natural step for them, because they are not longer relying on their own IT infrastructure, on their own perimeter system, on their own antivirus system. They want to rely on a bigger infrastructure, on the stronger firewalling system, on the stronger perimeter security system, and that is one reason why cloud adoption is also now, especially in the industrial world, is now catching up, and we see the trend in this market. And to be honest, I'm a business developer here for this industrial market, and that is exactly what we also see from our business, that our cloud offering is it's also very welcome, a cloud offering for PKI in this industry. Once you don't have to take care about the infrastructure itself, and second, we're also offering this managed service, so that you can also add or consume this PKI technology hosted by experts.
So Andreas, can I ask a question actually, because you mentioned earlier about self-signed certificates, and Siemens again having that in the manuals about recommending that, and now saying, okay, no, we're not going to do that anymore. We're going to recommend something more robust.
Right.
And there's a stat here on the page that says an outage due to a certificate likely being invalid or expired, right, could cost over $2 million euros if a system goes down, right? So can you just talk a little bit more about self-signed certificate? What does that mean, and then what is the better option here?
Yeah. I think so. Our audience is is smart enough to follow this, and let me start with the basic itself. So to secure a communication or communication channel in an IP-based network, TLS is the preferred choice for establishing a connector, an encrypted channel. To make it very simple, to switch on this encryption based on this TLS protocol, you need a certificate. And looking on this point and looking from outside, he says, okay, with a certificate, you can switch on the encryption, then I have a secure channel. Okay, why I do need a certificate anymore? I only want this encrypted channel. And then there is where self-signed certificate comes into place, because nobody explained, especially the industrial market, why certificates are so important to establish a TLS connection. Because you must, before you're starting to establish an encrypted channel, you have to identify your communication partners, vice versa. So if I'm starting and I want to start to communicate to somebody in a network, I want to make sure that I know the entity I'm communicating with. That, and vice versa. Also the server itself, who gets a request from myself wants to know who is it, and is he allowed to communicate with myself. And that is exactly what X.509 certificates are used for, especially in the TLS stack. And that is skipped completely by using self-signed certificate, because it's so easy to fire up your command line and start OpenSSL and generate a self-signed certificate and publish the signing key that you are using, the certificate from the signing key to the end entities, and then you can start to make a connection. One point everybody or very often get lost is that all these certificates have a validity date inside, and that's a time bomb. So when you are starting, open up your OpenSSL command line, and you are starting generating your self-signed certificate, there's one point where this tool is asking you, what about the validity? Validity till 5 years, 3 years, 1 year. Nobody knows what the guy who generates the certificate entered. And this certificate is operate in an operation environment, and once the validity is gone, and it's no longer valid, this certificate, the communication channel is not being established, and that causes the outages.
Yep. And these systems, right? Josh, right? They could be out there for 30 years or 20, 30 years, right? So this is something we've got to, again, it's about implementing the right sort of device identity. And I think there's a question here about system identity, right? So why are these OT systems so susceptible to attack? Do we not have this system identity, right? Because we're just trying to focus on the perimeter. And is that an answer? So I think we'll get into this a little bit here in the next couple of slides, but I think it's becoming more adopted again as we have these conversations and we see how people are implementing it and testing it out, because we have this longevity of equipment and systems that need to work for a really long time.
Mm-hmm.
Yeah, and when we talk about the growth through acquisition, when you acquire another facility, you inherit all of these self-signed certificates that you have no knowledge of who created them, when. And like we talk about, the life cycle in IT might be 1 to 3 years. It might be 15 to 20 years for the industrial devices. So there's definitely lots of places to trip yourself up there.
Yeah,
it's important to manage.
I'm not talking about the hacks that are possible when you're using self-signed certificate, but because everybody can issue a self-signed certificate, and everybody can, in the end of the day, can enter everything. And so we are at the starting point of the TLS encryption, where man in the middle attacks were easy and were especially in the internet, were on a daily business. That was ages ago, and that is exactly what we are seeing here today. When we are going through the manuals of named component manufacturers in the market, when they are describing how to secure the communication, normally you see a chapter inside these manuals how to generate a self-signed certificate.
Awesome. Well, let's keep going. I think
okay.
I would like to talk about standards.
Right.
What are you guys seeing? So maybe Andreas, if you could give us an overview of what we are seeing, what our customers and partners are trying to follow, and then how does that help us to shape what we do here?
Exactly. I think in the end of the day, I make it very simple. Simple and straightforward, because in the end of the day, there is no complexity today, luckily. So I think the overall framework and everybody is relying on is the IEC 62443 with the different kind of chapters and parts that are in the way, and they are addressing the whole ecosystem, or not the ecosystem, the whole stakeholders in the whole market, the component manufacturers, the machine builder, and the operators. That is all completely covered by IEC 62443. Although we have in this different part, some parts today are not published, they are also under work. Here we have also chapters how to develop secure devices, how to operate secure infrastructure, how to establish secure remote access, and so on and so on. And of course, IEC 62443 is also defining security levels. Security levels, based on different kind of parameters. So looking more on the hacker side, how trained the hacker is, how much money do a hacker has, how much resources do they have, how much time do they have, and what about the motivation to access and to hack your facilities. And based on this motivation, they are deriving levels, and they are also deriving the requirements and the parameter that have to be fulfilled to reach this different kind of level. Overall framework, from my point of view, perfect structure. Sometimes it looks a little bit weird and complex, but in the end of the day, it isn't so. It's very structured. Based on this, we see, especially here in Europe, that on the European level, so for whole Europe, but not national-wide, we see that different kind of regulations and directives are coming up. So the Cyber Resilience Act that was published and released last year, the NIS2 Network and Information Security Directive that was also released in January this year at the European Union, and that makes a huge impact on the product. It's not so. First of all, NIS was also addressing the critical manufacturers are working in the critical market, but nowadays they are open it up and now addressing a broad range of the industrial market when it comes to requirements about security implementation. And last but not least, and that was very silent, but they are now getting more and more into the focus of the machinery builders. Here, the machinery directive was released in June this year, where we see where with a big goal to increase the trust in the digital technology that are used in machine builder environments. And all of them are now in place. All of them are now active. And we are now in the transition phase. And I think we will see solutions, requirements, certification schemes, and everything are coming up now. I think so the deadline's more or less at 2026, where all these regulation and directives are getting into place. Coming from down of the technology, we are looking into the industrial standard. They are all also picking up security mechanisms. And also when it comes to PKI and the usage of digital identities and PKI technology, here's one. OPCUA is also addressing this with their well-established Part 12 when it comes to the discovery and global services, where certificate management is built in, and where the certificates are distributed to the client and the server components. And with the Part 21, which was released, let me don't lie, I think it was end of last year, beginning of December, the first version of Part 21 was released. That's the secure device onboarding. And they are addressing exactly one missing or one gap in this area. That means if every vendor is coming now with a digital identity and in their component, and if this component is mounted into an OT network and is connected to an OT network, it must establish trust. Not on the good old concept trust on first use, but establish trust on I know the communication partner, and then the communication partner knows me as a trusted device and a trusted network infrastructure. And that is exactly what Part 21 is described. Plus the Brisky RFC 8995 bootstrapping protocol is also hitting the same area for secure onboarding of devices with their identities. An overall standard that is for ages in our market is the IEEE 802.1 AR secure device identity standard. That's a good all wireless LAN standard that we all have in our house, wireless routers. And they developed, I think it was 2006, 2008, they developed the standard how to issue device identities, and then in the next step, how based on this device identities, how to issue operational identities in the field, deriving to the industrial market, how to generate device identity for a component like a PLC, and then in the next step, how to derive of this different kind of component I have in my machinery environment, so an overall identity for the machinery or for the component for the network itself. That is explained in the 802.1 AR. And that's in a nutshell, for a view on the market itself, on the market, the standard itself, where we see now, and which are also addressing us as a PKI technology vendor, and that are our guidelines, and that's it.
Great. Awesome. Well, let's get a little bit more into device identity. So as you're moving ahead there, Andreas, I am going to pull up a question here from Frank, who
Yes, please.
says, as we're scaling operations, so again, back to the people who are already adopting this, and that's, again, we saw a decent percentage there. How are we ensuring that the use of X.509 certificates remains scalable and maintainable when we have a large number of assets, endpoints, likely distributed, maybe global factories or global sites? So maybe as you get into describing a little bit in the next couple pages about device identity, can you keep that in the back of your mind too as well, answering how we do this at scale?
I think one point that is something, and very often I hear this question about scaling and growing and also being a solid partner, being long term in the market. My answer is very clear. Hey, this technology and this technology, this PKI technology that we are providing, this is used for infrastructure for issuing passports, driver licenses on a national level. And
Great point.
and that is something. Don't ask them how do they scale their infrastructure. That is in the end of the day, that's built in into our technology, because that's one major building block. Also, when it comes to security, security requirements for secure connection is encryption, integrity, authentication, and reliability. And reliability is built into the PKI. And I think so. To be honest, I'm in the market for ages now for crypto and for all this stuff here. I'm not scared about these numbers of devices that are out in the field.
That's a great
let's
point.
talk a
Thanks for
little bit
sharing
about,
that. Yeah.
I will also address this a little bit more in this area when we talk about secure device ID. So the starting point for everything, for the whole journey, and also for establishing a secure connection, there is a secure device identity. So in the end of the day, combining the physical component to a digital identity, in a secure and cryptographical manner. And therefore, you need, first of all, the X.509 certificate that is doing this. It's a data structure that is combining the parameters and specification parameters of the component with the crypto key material that is generated by this component, and it is attested by a PKI that this is true and it is valid and it is trusted, and this public key infrastructure stands for the trust in this environment. And that is the left-hand side of this picture here. We have the digital certificate of the device identity, and then the other question is, and that comes directly up. The question is, okay, where do we store all the crypto material? Because these are the assets, these are the identity itself. In our normal world, in our normal economy, secure crypto keys are stored in secure tokens. And we all have these tokens in our wallet, when it comes, for example, for the payment card. So payment technology is based on crypto keys, and these crypto keys are stored in a secure token in your payment card. Some of you remember the transfer between MagStripe to chip technology in the Mac and the EMV environment, in the MasterCard and Visa environment. So that is exactly the changing the crypto token itself. And that is something that you need also in this environment here. So we see also that many manufacturers are built in crypto tokens itself for like secure elements, TPM technology, that are silicons that are soldering on the PCB. But also, and that is what I will later on show you some use cases that we implemented with some partners. We are also seeing that crypto tokens in other form factors like USB HSM or secure SD cards with a built-in HSM are used for storing this crypto key and storing, in the end of the day, the secure identity. And that's a starting point. That's a starting point for the device ID itself. And now let's talk a little bit about how the implementation looks like. And here's one of our customers who are operating their whole public key infrastructure for issuing device identities for their product lines. That's Phoenix Contactor. I think everybody knows them, especially from the communication technology they are offering, edge gateways and remote access gateways. And so this is how it looks like today when we are looking into their catalogs of their components that they are manufacturing. They have a component. They have also a QR code on top of the component itself. Inside the QR code, there's a link to their infrastructure, where you can retrieve the vendor certificate to validate the identity. And that's important later on when it comes to the concepts. Yeah, and that is how they are implementing it. And all of them, and when we are talking to these guys, yeah, on which standard you are planning to implement all this device ID issuing process, they are referring to IEEE 802.1 AR. Yeah, as I mentioned, it's an old standard, it's around for ages. Yeah, but that's the basics, that's the foundation, yeah, for all upcoming functionality. So with this secure device IT, I can easily establish a secure device provisioning. I explained based on this concept from OPC or Brisky. Yeah, or I can establish a secure boot process. I can establish a secure software update. Yeah, trusted communication channels could be established then. Yeah, and so on. So that, but without this trusted device ID, that I know exactly I'm talking to a device that is coming from vendor A, and it is a trusted environment and it's a trusted configuration, that is essential in this point. And this, I think, in the end of the day, we are picking up also here on this slide the 62443 framework itself with the three different kind of roles in the market itself: the device manufacturer, on the left hand side, the integrator, machine builder in the middle, and the operator who is operating the machine. And in the end of the day, and that is also described in the 802.1 AR concept itself. The trust has to be established between all of these three parties in this channel here. And also the overall 62443 framework is referring to this model here. And on the left-hand side, the device manufacturer, he is generating the initial device ID that is burned in, and that is guarantee and that is proven the origin of the device itself, by combining the parameters with the crypto key, and issued this device ID by his infrastructure, by his PKI infrastructure. As I mentioned, Phoenix Contact is using PKI technology and operating a product infrastructure. Siemens is operating this. All of these device manufacturers, or more and more, they are now starting to establish this scenario. Once they are shipped to the integrators or machine builders and plan builders. So these guys, their job is to assemble everything in an OT network and setting up an OPCUA network or control network with all the sensors, the actors, and the controllers, and going up to the HMIs and everything. They are making use of these devices, and they are now in the position that they have to aggregate and to first of all validate the device identity from each manufacturing site, and then over it or on top of this device ID, they could generate their own integrator ID of the whole machinery. That is called the LDEF ID. And you're looking into the standard, and sometimes maybe you hear this, that is a typical concept, and that is designed and standardized by this IEEE standard. And it's also part of the 62443 that an LDEF ID is needed. And with this operating identity, we can now start into the operational side, provisioning the machinery into the monitoring environment, provisioning them into their operator side SCADA network. We could enable remote access to the machinery, and so on and so on. And that's the concept itself. And that is, I think, the foundation of that, and the underlying foundation, that's the 802 IEEE standard. And if you want to see it in real life, and that is what we showed also this year showed this year during the Hannover show, and we showed a complete implementation of this stacker. And we open it on GitHub. So if you're going to Key Factors GitHub repo, and you can point your engineers to it, they can have a look inside, and we implemented the whole stack and to showcase how it looks like in the field, because we are receiving so many requests from interesting parties, from partners, and also from customers. Do you have some reference implementation? Do you have some guidance how to adapt this standard? Because it's a standard, it's not a code book. Yeah. So, and that was the motivation for us. And we are stopping this discussion and we are implementing an example. Yeah. And we are showing also how to configure the PKI. Yeah. On the backend side. Yeah. How an IDEF ID is configured, how an LDEF ID certificate is configured in a PKI side. Yeah. Because an IDEF ID is, from the validity, is infinite. Yeah. How to configure it, how to integrate or how to issue an OPC server certificate, where you have to build in several IP addresses, but only one URI. Yeah, and so that is also part of this publication on the GitHub. And that's a good point. All of this functionality is also operated and also available with our community edition. Also, that means also our open source component is working with this implementation here on that side, because our decision is, or we made the decision that also we want to enable this technology in a very early stage to the market. And that's the reason why we decided to also add this, or we are adding, or we are describing this with our open source technology.
That's great. I think, so Andreas, we've got a couple questions here in the chat that maybe we can start to go to. But Josh, maybe before we do that as well, anything from your perspective that you want to add to this, obviously coming from the industry and knowing that there's different protocols from, Siemens, Rockwell, ABB, there's interoperability that factory and operational people have to deal with, because not one vendor is making all of this stuff. Things have to interact, so that involves complexity. And how do you see that coming to fruition in the real world when it comes to us implementing what we've just been talking about, and relative to meeting these standards? Like, how do you see that actually working?
Sure. Yeah. So one thing we haven't mentioned yet is the gray market. We're talking about how important it is to establish trust from the very beginning of the supply chain all the way to the machine builder and the end users and the factories. Especially over the last several years, we've had a lot of supply chain issues. And these machine builders, they have to get these giant machines out of their building to start with the next machine. And sometimes there's just a PLC or some IO or some smart devices holding them up from shipping. So they go to eBay and they go out and they buy these devices from different sources, and they might say Siemens on them, or it might look just like an Allen Bradley part, but inside it's not. There's a lot of equipment running factories today that is not authentic equipment. So I think by establishing trust like this in the very beginning, you can guarantee that your customers are getting the right equipment, because there's power and infrastructure that is running on gray market devices, and you don't know they're gray market until you try to update the firmware or they fail on you. So I think the whole concept of establishing trust end to end, to me, is a huge benefit.
Yeah,
that's a great comment. Thank you. Okay, so let's go to a couple other Q&A here. So maybe talking about legacy. So someone's asking, how do you deal with machines that have these legacy operating systems? And if we're cost effective in the way that we're trying to set up and run operations, we there's a balance there. We don't want to put too much in. Like, how do you think about upgrading what's in the brownfield perhaps, and justifying cost when we saw some of the numbers here about numbers of or dollar amounts or euro amounts what you got to pay for breaches or outages? Like, how do you deal with legacy systems? And either one of you can answer that.
Well, I think with some machines, it's a risk-based thing. So you want to protect what makes you the most money. So if there's a chance of substantial loss and it's a low probability, that might still be more important than something with a high probability but very low impact. So you got to look at it from a risk-based view lens. But then also there are certain machines that maybe you can't land a certificate on, and you just want to segment them. Kind of. I think so. It's case by case basis, and you just got to look and see what's the highest impact. What do we need to protect and put our arms around, and what do we need to just segment off?
That's a great question. And I think Rashid just asked that question as you were speaking. So how do you decide, and maybe Andreas, what have you seen implemented? It's not every device in the whole system, right? What is the criteria by which you decide what to prioritize, placing the security on at what level, and how do we go about that? So maybe it's a phased approach, like not every single thing that we can secure right now, but where do you start?
Yeah. I think in the first of the day, start from the component who is as closest to the connectivity and the internet in your environment. For I give you an example, an edge gateway who's bridging your OT network or your machine network to a cloud service. That is something you have to take, first of all, focus on that and see if it's properly managed and if the stacks are or the TLS stack is properly implemented, if the certificate could be managed and everything. But on the other hand side, you also have to decide if something is operated in an untrusted environment, then you have to make a secure connectivity. For example, if you are establishing a pure and simple MQTT network, and your broker is prominent in an untrusted environment, then you must secure the connectivity, and you must enable, you switch on the TLS stack. So that is also, and it's the same also at Josh that you say it's by case you have to decide, and you have to evaluate the risk, and you have to understand the risk of the component itself that you are implementing.
Yeah, I think sometimes people might have a 2 or 4 year plan, but then once they get attacked, it turns into a 6-month plan real fast. And so, when you're asking for budget and money, it's not an overnight thing, and there's a cost to securing your OT environment. So yeah, case by case. And as Andreas says, you got to look at what's the most vulnerable as well. So a lot of factors.
Right. Cool. Okay, here's another one, and I don't know if we have an answer for this. I'm not familiar with it, but I'm going to throw it out here in case either of you have heard. But so Dave's wanting to know about decentralized identifiers and trust over IP model. Is that something you guys are familiar with? And is anyone in this industry looking into that approach? Any thoughts on that?
I saw this question here popping up now, and considering decentralized identifiers, yes and no. We saw this concept. We saw this. How can I say this? We saw all these startups over the last decades before COVID. Especially these coming up now, and we saw them also going down because it's in the end of the day it's too early. It's nice to think about such concept, but we are in an industry where it takes years to introduce a new feature. So once Siemens now announced the release of the GDS and their OPC-UA PLC Siemens add-on for the Simatica, you will see it in the market a year later, the first implementation. And that is what I saw, that yes, this technology is valid, and that it's absolutely also, I see some application areas for this technology, but not with the IT startup mentality in this market. where you don't have time to develop the market. Yeah, because it takes time. And that was the reason why many of those startups were pushed, and after 1 year they are going down because they didn't have any success in this area.
Got it. Okay. All right. Well, we are almost out of time. So before we wrap up and move to the next session, I would just like to give each of the presenters to maybe 30 seconds, 45 seconds of a parting thought, like something either we didn't discuss yet, although we covered a lot, or maybe just if the audience wants to remember one key thing, what would you say? So Josh, I'd like to start with you.
Okay, sure. So I guess I like the part of the discussion about going to the cloud for security. I know in the early adoption stage, people were afraid to go to the cloud. They wanted to protect their data. And I think that when you move things to the cloud and you use technologies like PKI to facilitate the encryption, I think you can safely go to the cloud and you can check off a lot of boxes right off the bat. So you have a server in a closet here behind a door and a window at your facility. Or do you have a server in the cloud and you've got redundant power, you've got internet fiber coming from the east, some coming from the west, disaster recovery with multiple data centers. So I think that PKI and the technologies we talk about are going to really enable the OT industry and plans and manufacturers to move to the cloud safely. And I think it's going to definitely help with the security and prevent things like ransomware and things like that. So I think people think of cloud, they think of predictive analytics, but it's also for security,
That's a great point. Great point. Thank you, Josh. And Andreas, what would you leave the audience with today?
I think that is every time when I'm on this audiences here in these conferences, my word is start today implementing PKI technology into your organization and into your OT network. Because you have today we have so many use cases for PKI. Only to issue a certificate for an OPC UA server or for your MQTT broker. Yeah, that's the first use case. So start today with this technology. It's not a failure of investing in this technology, because PKI technology is around for ages in the market. It's not a startup, a hype technology that is developed over the last 2-3 years. It's a solid standard-based technology, and we are following standards. And we don't implement crypto stuff that is not published to the outside world and is not recommended for the NIST by the NIST. So start today. You have the technology, you have the use cases in your in-house environment, and also establish around where you're thinking about or adding this functionality into your product strategy, and learn from other companies how they did it. So when I'm talking with Siemens, I'm talking with Phoenix, and I'm talking with them about their strategy, about products, about on-demand services, on license selling for their technology and their products. PKI is an essential part, and it's the underlying foundation for trust, security, and protecting in the end of the day, their money. For this coming new models, that we want to see also in the industrial market. That's my 50 cents.
Well, thank you so much, guys. And a poll here, please rate this session. We'd love to get your feedback. Just want to say thank you to the presenters, Josh, Andreas. It was so great to have this open dialogue. There's some additional links here. Again, we're from Keyfactor, right? But like Andreas mentioned, we collaborate with a lot of others in the industry. So these are not only our thoughts, but those of our partners and our customers. Quick thanks again for today's session, the sponsors, and a plug for what's coming next. Okay, so top of the hour, we'll be having another session around OT secure remote access. So how to benefit from zero trust networking. And so a great panel looks like from Cisco, WWT. So stay tuned and sign into that in another minute or so. So with that, just like to say thanks again. Thanks IIoT World for having these great sessions and good conversation, and audience. Love the questions. Thank you for the engagement. Right on.
Thank you.
Thank you.
Take care, everyone.